Hello, my name is Rohan-Paul, and very welcome to my computer vision and deep learning YouTube channel. Let's get started. So in this video, I will implement mean intersection over union, or Mean-IoU. So mean intersection over union is a common evaluation metric for semantic image segmentation, which first computes the IOU for each semantic class and then computes the average over all the classes. And so this is the formula for calculating the IOU, which is true positive divided by true positive plus false negative plus false positive. And here true positives are those pixels that belong to the class and are correctly predicted as that class. False negative are those pixels that belong to the class but are incorrectly predicted as a different class. And lastly, the false positives are those pixels that belong to a different class but are predicted as the class. Let's take a note of this image right here. So obviously the leftmost image of the dog is the original training image. And so I have then three masks, and the first mask over here is the expected mask because that exactly resembles the dog sleeping over here. Then I have this mask predicted from my model, and then the last one is actually showing the difference between the ground truth mask, that is this expected image, and the predicted mask. And note these three colors here: red, green, and yellow. So in this last image, all the true positives are indicated by the yellow pixel, false positive are indicated by the red pixels, and false negatives are indicated by the green pixel. And once we have these difference between the predicted and expected mask, we should be able to calculate the IOU, or intersection over union, by following these mathematical expression. And now the Mean-IoU, coming to the main point of this video, that is a Mean-IoU. So that's determined by these pseudocode. So for each class, calculate the total area of intersection and area of union over the entire data set. Then for each class, calculate the IOU, which will be the total area of intersection divided by total area of union. And then lastly, calculate the MIOU, or the Mean-IoU, as for each class, all the class together. And with that, now I'm going to implement a simple MIOU method with Pytorch. And also note that these IOU, or intersection over union, is a value between 0 and 100, where a larger value indicates a more accurate segmentation, and the MIOU is then the mean value across all the classes in the dataset. So first import torch. Also I need to import torch.nn.functional as f, and then my method def Mean-IoU, that will take a predicted label, then a label. It will take a small value for smoothing. I'm calling it epsilon or EPS. Let's give it 1e minus 10, and num classes. Let's just give a default value of 10. And because I do not need the gradient tree of Pytorch tensor, so I will start a context manager with torch.nograd. And I'm going to make use of softmax over here, and that's because these predictions of your model, that is this predicted label, will be in one hot encoded form. So first I'm taking softmax, if your model already is not taking the softmax, to get some probability. So that would be f.softmax predicted label dim equal to 1. And then after taking the softmax, I need to follow it with the argmax to get the index with the highest probability at each pixel. Predicted label, oops, sorry, predicted, I just want to have predicted label equal to dot max. That will be predicted label across dim to 1. And then I'm going to make use of torch.contiguous to make my to create a copy of my tensor, and where the elements will be in a contiguous fashion. So predicted label equal to predicted label dot contiguous pi minus 1. I have to do the same for the label vector as well. Contiguous minus 1. Now let's define a list variable to hold the IOU for each single class. So SINGLA class would be, yep, for class number in range. I'm starting a loop from 0 up to class number, and my number of class is coming from my this argument num classes. And this is very much where I'm looping per pixel class. And inside the loop, my true predicted will be true predicted class actually. That will be where predicted label is equal to class number. That's my true predicted class, and true label would be where label equal to class number as well. Now if true label dot long dot sum, I'm chaining few methods here, dot item will just extract the value from the tensor. If true, spelling mistake, true label equal to 0, that is no existing label in this loop, then my IOU single class dot append will be in p dot, I'm going to use not a number, man. I have not imported numpy. Let's do that. All right. And now I have that condition fulfilled. So if that is not the case, else my intersection, okay, now let me think. Yeah, in this case my intersection will be torch dot logical and that will take true predicted class, then it will also take true label, and then I have to do sum dot float dot item, and my union will be torch.logical or, and that I will pass true predicted class true label sum.float.item. All right, now my IOU will just be the division between these two numbers, but of course I have to adjust it with my epsilon value for smoothing. So that would be intersection plus EPS divided by union plus EPS. And I also need to append this IOU to single class.append IOU. Cool. So I can come out of the loop and I can return the average of all these, which will be np.nan mean IOU single class. Now, couple of points to mention here. This method right here, contiguous. Note that it returns a contiguous in-memory tensor containing the same data as self tensor. If self tensor is already in the specified memory format, this function returns a self tensor itself. Now, tensor.contiguous will create a copy of the tensor, and the element in the copy will be stored in the memory in a contiguous way. Means the order of its elements in memory is the same as if it had been created from scratch with the same data. The contiguous function is usually required when we first use transpose on a tensor, and then we use we view or reshape it. Now, also I want to mention about these function logical and also logical or. So logical and computes element wise logical and of the given tensor. Zeros are treated as false and non-zeros are treated as true. And I did it here, that is logical and here to find where prediction and target are equal between two input tensors. Note here that the two input tensors themselves consist of true false, that is Boolean type. So this was just one way to write this method to calculate the mean IOU, and while the concept remains same, that is underlying mathematics remains same, you can write mean IOU method in slightly different ways. Actually, if you go through many GitHub repositories or many others code who have implemented this mean IOU in various section with either NumPy or Pytorch, you will find slightly different ways to write this up. So I'm also going to use a slightly different style to do my mean IOU calculation. So just write another method here. So this is just alternative way to calculate IOU. Sorry, mean IOU. Alternative mean IOU calculation. So my second function, let's name it as mean IOU. It will take a target and also predicted. Now I'll do slight assertion testing at the very first step. If target.shape not equal to predicted.shape, then target, sorry, where as RGET target dot shape, and also predicted values have a certain shape, predicted that shape, and then just put return. Also another assertion test, if because I'm dealing with Pytorch image dataset here, and I'm expecting the dataset will have 4 dimension, that is batch size, channel height, width. So I am going to do target.beam not equal to 4, sorry, not equal to 4. In that case, print target has been it not be 4. Return. And now my final actual calculation of IOU. So let's define the term IOU sum equal to 0. Run a loop for I in range target.shape 0. And now I'm going to make use of slice notation to include all the dimension, all the elements of each of the dimension after the first one. So that will be 1 slice, 2 slice, 3 slice. And now I'll be chaining together few methods. Clone dot detach to detach the gradients tree, CPU, taking all calculation to the CPU dot numpy, and then finally argmax. I got to do the same for the predicted value as well. So let's just do predicted. Where is my, what was the name of, so that's predicted. Yeah, let's call it predicted, or then it will be predicted. Otherwise, the rest everything will remain just the same. All right, now intersection is equal to np dot logical and to that I'll pass target ARR, then predicted ARR dot sum, and union will be np dot logical or target array and predicted array dot sum. Now another little assertion test before the final calculation. If union equal to actually equal to 0, in that case just return IOU score as 0. Score as 0. Because in that case there is no union at all. Else IOU score will be equal to intersection by union. Now I can come out of the loop and update my IOU sum plus equal to IOU score. And finally, my MIOU, that is Mean-IoU, will be IOU sum divided by target.shape0 and return MIOU. So that was two alternative way to do this calculation of Mean-IoU, and now the final and the third alternative way, because till now we used mostly Pytorch kind for both of these methods we used Pytorch as an underlying framework that I'm using to build this. But now in the third alternative I will use pure sklearn, scikit-learn. Third alternative to build MIOU. All right, let's do this. Div. Okay, first I need to import scikit-learn. From sklearn.metrics import. I need confusion matrix because that will give me the matrix containing the true positives and true negatives, all these things. And now my method, div Mean-IoU. So I will have y prediction and y true. Now first I'm going to flatten these vectors, so y pred will become y pred dot flatten. Similarly, y true will become y true dot flatten. And now my confusion matrix should give me the matrix containing. Now before doing the confusion matrix, quickly check the definition. So here I am in scikit-learn's confusion matrix official documentation. So it compute the confusion matrix to evaluate the accuracy of a classification. By definition, confusion matrix C is such that Cij is equal to the number of observations known to be in the group I and predicted to be in group J. So this is the key thing. And if I go to, so it will take y true, y pred, and it will also take another argument labels, which is an array-like of shape, number of classes, and default is none. So the return value from the confusion matrix is a matrix which is of ND array of shape n classes by n classes. So confusion matrix whose this is a matrix whose ith row and jth column entry indicates the number of samples with true label being ith class and predicted label being jth class. And that's all I need, because once I get this matrix, then from this matrix along the diagonal I will get my intersection points. Yeah, so let's actually just go and start coding, then it will be, or it will make sense. Confusion matrix will become, actually what I'm doing, confusion matrix will give me y true, then y pred. I also need to pass a label select, because here my labels are binary 0 1, Actually, to avoid some ambiguity, let's name this confusion tensor. All right, now what I'm going to do, compute the mean IOU. So for that, I first need the intersection points. So my intersection will be equal to np.diag. Again, if I go to the official documentation of np.diag, so this extracts a diagonal or construct a diagonal array, and then it says see the more detailed documentation for numpy.diagonal. If you see, if we use this function to extract a diagonal and wish to write to the resulting array, so parameters, it takes v array like k, an integer. All right, and what does it return? It returns the extracted diagonal or constructed diagonal array. So if we see an example first, here there is an example. First, they're building a matrix with np.a range 9 reshape 3 by 3. So this is the matrix that we just built with this code here, and now my diagonal will be this number 048, that is they are along these diagonal. And once I do np.diag x, I get the output array as 048. That's the vector I get, and that's what I want for my intersection, because here, here, and here, the prediction and the true labels are actually equal, and that's what I want. For example, if you can see in this matrix right here, the row number here is 2 and the column number here is 2. So row number 2 and row number 2 and column number 2 matches in this place. Similarly, row number 1 and column number 1 matches in this position. So along the diagonal, I get my intersection points. So that's what I want. np.diag con confusion tensor. Oops. fu confusion tensor. And then my ground truth set will be ground set will be confusion tensor dot sum along axis of 1. That will be my ground truth set. And similarly, my predicted sets will be confusion tensor dot sum x is equal to 0 along the rows, that is. And now union will simply be my ground truth set plus predicted set minus the common area, which is intersection. Otherwise, I'll be counting intersection twice. So ground truth set plus predicted set. From there, I minus a deduct intersection. And finally, IOU is equal to intersection divided by union dot s type np dot float 32. All right, return. What do I return? I need to take the average of all these. So np dot mean IOU. Perfect. Let's quickly see an example of this. So what I will do is, second, let me copy this thing, and oh, I need to copy import. That is only, I'm copying only the third alternative to build MIOU. So I'm going to a Jupyter notebook and just pasting that code. Let's just, am I in a code cell? Yes, let's just run it. I just want to see a use case of this method that it's actually working. Okay, I need to import numpy as NP. All right, now I'm just going to define two basic metrics with np.array. Let's give inside this one, and I also need to define y, the second set of y, which is y predicted. np.array. All right. And now what I will do is Mean-IoU to that. I will pass y true. Sorry, first one will, what was the first argument? Y pred. Yep. So give y pred and y true. Let's run it. NP is not defined. Okay, define it. And now run it again. And there I go. So that's a value for my mean intersection over union. So yeah, what we did basically, three alternative ways to build the Mean-IoU, which is a very important metric in object detection and semantic segmentation problems. That pretty much wraps up this video, and all my upcoming videos will all be on some great computer vision projects and algorithm with Pytorch and Tensorflow. So stay tuned, and if you have not subscribed yet, do subscribe. And if you like this video, smash the like button. Thank you for watching.